Hello everyone, I am Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So, in the subject of Basic Electrical and Electronics Engineering, today I am going to discuss about the topic Basic Definitions. So, we will start our topic with the term charge. So, what is a charge and what is electricity? So, before going to the charge, we should learn about the atoms. So, what are atoms? So, all the matter is made up of a fundamental building blocks which are called as atoms. So, these atoms consist of electrons, protons and neutrons. These atoms consist of electrons, protons and neutrons. So, electrons are negative charge, protons are positive charge and the neutrons are neutral. So, as I had shown in this diagram, this negative charge indicates the electrons and this positive charge indicates the protons and these are neutrons. So, electrons, protons and neutrons. A charge is nothing but a fundamental property of the matter which influences the behavior of the particles. So, what are behavior of the particles means, as I had told you before, atoms consist of electrons and protons. So, like charges repel each other and unlike charges attract each other. So, this charge is nothing but the basic property of the matter which influences that behavior of the particles which gives rise to the electromagnetic force which is very much useful in the electrical terminology. And this charge, whether it is positive charge or negative charge, it is indicated by the letter small q or capital Q and it is measured in coulombs. The units of charge is coulombs. So, now coming to the electricity. So, what is electricity? So, the flow of electrons is called electricity. The flow of charge, we can say that the flow of charge is called electricity. So, now coming to the basic terms in the electrical terminology, current. So, what is current? So, before going to the current, we are going to learn about the types of materials. So, materials are mainly classified into three types. They are conductors, semiconductors, and insulators. Conductors, semiconductors and insulators. So, what are conductors? The materials which allow the free flow of electrons through it is called conductors. Examples of conductors are all metals. Metals like copper, aluminum, etc. So, all these comes under conductors. So, next one was semiconductors. Semiconductors are the materials which allows the partial flow of electrons through it. Which allows the partial flow of electrons through it are called semiconductors. So, examples of these semiconductors are germanium, silicon. So, next coming to the insulators, which does not allow free flow of electrons through it is called insulators. The materials which does not allow free flow of electrons through it is called insulators. So, examples are wood, rubber, etc. So, all these comes under the insulators. So, now why I had discussed about the types of materials was, so all the electrical terminology deals with the conductors because the flow of electrons will takes place in the conductors. What is the definition of the conductor? Which allows the free flow of electrons through it. So, as we are dealing with the electrons, so in our subject, this conductors plays a major role. So, now coming to our basic definition, electric current. So, what is a current? Flow of electrons in a unidirectional manner is called current. Flow of electrons in a unidirectional manner is called current. So, why I had mentioned as unidirectional manner means, generally, if I had taken any material like this, any material means conductor. So, there will be a flow of electrons. There will be a flow of electrons, but the flow of electrons will be in a different direction. Means some will flow like this, some will flow like this. So the flow of electrons will be in a different way. So if there is a disparities or differences in the flow of direction of the electrons, then we can't determine the direction of the current. So we have to forcibly make all the electrons to flow in a unidirectional manner. So initially in this material, the flow of electrons are in random directions. So now I am making all these electrons forcibly to move in a unidirectional manner. So why I am doing like this means only if the electrons are in unidirectional manner, then only we can determine the direction of current. So for that sake, I am forcibly making all these electrons to flow in a unidirectional manner. That force which we are making the electrons to flow in a unidirection is called voltage. Which I am going to discuss in the next slide. So current means the flow of electrons in a unidirectional manner is called current. So how the electrons are flowing in the unidirectional manner means by applying the external force which is called as voltage. Current is indicated by I and the units of current is ampere. So finally we can determine what is electrical current means. Electrical current is nothing but the rate of flow of electrons in a unidirectional manner in a conductor. So in a conductor, flow of electrons in a unidirectional manner is called current and the unit of current is ampere. So now we are going to discuss about the important topic in the electrical terminology called as voltage. So what is voltage? So before going to the voltage, we have to discuss about the atoms. So as I had told you before, we are having positive charge as well as negative charge. So like charges repel each other and unlike charges attract each other. So while the charges are getting attractive or getting repulsion, whatever it may be, it will come closer or it will move away from each other. So while it is getting closer or it is moving away from each other, whatever it may be, there will be some amount of potential for the charges. So this potential will be there for different charges. That electrical potential which is present in the charges, there will be a difference because of this attraction or repulsion. So that difference in the potential of the two charges is called potential difference. And this potential difference in the electrical terminology is called voltage. So the difference in the potential of the two charges is called potential difference, and the potential difference in terms of electrical terminology is called voltage. So potential difference and voltage both are same. And the voltage is indicated by V and the units of voltage is volts. So what is the function of voltage now? So as I told you before, current. What is meant by current? Flow of electrons in a unidirectional manner. So how electrons are flowing in a unidirectional manner? So we are giving or we are applying some force to flow all the electrons in a unidirectional manner. That force which we are giving for those electrons are nothing but voltage. So with the help of voltage, the current will flow in the circuit. So the generation, transmission as well as distribution of electrical energy. So generation means how the electrical energy will be generated. There are different forms of generation of electrical energy like solar, wind, hydel, tidal, nuclear and so on. So in all these, AC voltage only will be generated. And this generated voltage will be transmitted through the transmission lines, and from the transmission, the distribution will take place with the help of the distribution. So these generation, transmission, distribution, everything voltage only will be transmitted. Means generation, transmission, distribution, everything will be done through voltage only. So a voltage will be generated, voltage will be transmitted and voltage will be distributed, and finally the load will draw the current from the voltage. So voltage and current plays a major role in the electrical terminologies. So next, coming to the currents. So we are having two types of currents called as AC and DC, alternating current and direct current. So currents are classified into these two types, alternating current and direct current. So now we will see the differences in between the alternating current and the direct current. So based upon these direction of current, voltage, generation, transmission and ripple, Based on these factors, we are going to differentiate the AC and the DC. So coming to the AC. So how in AC, how the electrical energy will flow? Means the flow of electrical charges will reverse at regular intervals. So at regular intervals like 0 to pi, 2 pi, 3 pi. So likewise, so the AC waveform will be like this. So see here, as we are seeing here, the flow of charge reverses the direction here at regular intervals. So 0, pi, 2 pi. So at regular interval of time, it is getting changed. So in alternating current, the flow of charge reverses the direction. But in the direct current, this is DC current. So in the direct current, the flow of electrical charge will be constant and it won't change the direction with the term of direction of current. Next one was voltage. So voltage, it constantly changes the magnitude and direction. Why? Because as we are seeing this waveform, this is AC and this is DC. As we are observing the AC waveform, it constantly changes the magnitude and direction. It is flowing in this direction, later on it is coming to this direction, later on it will again flow this direction, later it will come in this direction. So it is keep on changing its magnitude and direction. But the DC, there is a constant flow of current. So coming to the case of generation. So the generation of AC will be done through power stations. Power stations means, as I had told you, there are different types of power stations like nuclear power station, thermal power station, solar, hydel, wind. So many are there. So in all these power stations, the AC will be generated. So the DC will be produced by the batteries, solar cells and other sources. Next, coming to the transmission. So AC is very much flexible. So we can increase the voltage or decrease the voltage very frequently when the voltage is in the form of AC. So how we can change the voltage? So there is a special device called as transformer which plays a major role in increasing the voltage or decreasing the voltage. So transformer plays a major role to step up the voltage or step down the voltage. So in the generation also, we are going to generate the voltage. So after that, the generating the voltage, we are going to transmit the voltage. So before going that, we are going to step up the voltage. We are going to increase the voltage and then we'll transmit the voltage. Later on again in the substation, we are going to step down the voltage and we'll send it to the distribution purpose. So for all these, we are going to increase and we are going to decrease. So for these, increase means to step up or to step down, transformer plays a major role so that we can easily transmit the AC over long distances. So AC is more preferably used, and for long distance transmission also AC is more preferred when compared to that of DC. And DC is not suitable for the long distance. Anyway, nowadays high voltage DC transmission also going on, but when compared to the AC, DC is not that much flexible and that much safety also. Next, coming to the ripples. So when compared to AC and DC, the AC will not have ripples as the direction will changes frequently. But coming to the DC, there will be rectification procedure. So with this rectification procedure, there is a possibility of having the ripple if it is not rectified smoothly. So when compared to AC and DC, AC is more preferred when compared to that of DC. So now let us see the word power. So what is a power? So power is nothing but the transfer of electrical energy within a circuit. Within a circuit, how the electrical energy is transferred. So the unit of power is watt and power is denoted by the symbol P. And the unit of power is watt. And it is also defined as joule per second. And in the terms of voltage and current, we can determine the power as power is nothing but the product of voltage and current. In the electrical terminology, we are going to define as power as product of voltage and current. So in general, we can define the power as P is equals to W by T, means work done by time. But in the electrical terminology, we will define it as product of voltage and current, because everything we here will discuss about in terms of voltage and current. So generally, we are going to discuss this formula of power. Now we are going to see the flow of electricity. So in this flow of electricity, the first step which we should learn is about the power plant. So what is power plant? The place where electrical energy is generated is called power plant. So this power plant will generate the electricity or electrical energy. So we can generate the electricity by using different means like solar, wind, tidal, nuclear, so on. By different means we can generate. But here I had considered the thermal power plant just for explaining purpose. So this power plant, from this power plant we are going to generate the electricity. So after generating the electricity, we are going to increase the voltage for the transmission purpose. So what is the need for the transmission? Why we should transmit means the generating places or the generating stations of this electrical energy will be far away from the city. So we have to send it to the far distances. For that we have to transmit this electrical energy or transmit this voltage with the help of transmission lines to the longer distances. For that we are going to use a important or special device which is called as transformer. As I had told you before, transformer plays a major role in the transmission of AC. AC means alternating current. So transformer plays a major role. So this transformer will increase the voltage. This generating station will produce the voltage. After that we are going to increase the voltage, and this increased voltage is sent to the transmission lines, and these transmission lines will transfer to the long distances because it have to serve to the loads. So after that, after sending to the long distances, this transformer, another transformer will use called as step down transformer. So this step down transformer will decrease the voltage. Here the transformer steps up the voltage, means it will increase the voltage here, the first transformer, but here the second transformer will decrease the voltage. This decreased voltage is sent to the distribution line. So this distribution line will carry the electricity to our home. So from here this distribution line is transferred like this. So here again we are going to use a transformer which is called step down transformer, because the voltage which comes to our home is single phase 230 volts 50 Hz AC supply. So to step down to 230 volts, here we are using another transformer. So this transformer on the pole steps down the voltage, and finally a 230 volts will be sent to our homes. So likewise the electricity is getting generated and it is transmitting to the longer distances, and it will finally reach to our homes. This is how the electrical energy will be generated and finally reach to our home. So these are the basic terms: voltage, current, power, charge, electricity. These are all the basic terms which we had learned in this class. And next classes we are going to discuss about what is Ohm's law, what are the types of elements and different types of analysis. All those we are going to see in the next classes. Thank you.